The next speaker is Mr. Jack Ashby himself. Nature's Memory, How Natural History Collections Help Save the World.
Hi everyone, so for those who don't know me, I'm Jack Ashby from the University Museum of Zoology in Cambridge. So I've been talking about this lately with the media quite a lot. People say, oh, this is a bold claim, right? That naturalist museums can save the world. But I think everyone in this room already knows that it's true. I think not so long ago, we as a community kind of have been saying that people have just been writing us off as being kind of dusty old collections, or paradoxically at the same time, also just for kids, which I think we've always known is not true. But I guess I'd be naive in saying that I think things have completely turned around. But I do think there is reason to be hopeful that over the last 10 or 15 years or 20 years, I think we can say that we've made major steps forward. So 6.3 million people visited the Naturalist Museum in 2024. That's only just slightly fewer than the British Museum, but in other years, the NHM has come on top. We know from our own research in NatSCA that naturalist museums are the most favorite kind of museum. So we all know that our collections are valuable. What I'm saying is I think other people are starting to catch on. And there's, as we know, we've heard, massive government funding for naturalist museums at the moment. There have been major museum developments across the world in naturalist museums. So I think things are getting better. And we all know, again, I'm telling you things you know, that we have been saying that the world cares for, the naturalist museums care for the best evidence in the world for environmental change and climate breakdown. And I think what I'm saying is that people starting to pay attention to that. So, our collections are vast, as you know. This is the most amazing place I've ever been in my life. It's if you're ever near the Smithsonian Museum, say, I'm from a naturalist museum, please can I see your stores? This is the whale warehouse. It's got 8,000 whales in it. The whole collection is 148 million. So you're in a room with 8,000 whales. My head, if you've ever stood next to a blue whale, my head comes up to here on this skull. It's astonishing. So the collections we know are amazing. And obviously the technological capabilities of making the collections more accessible and the scientific research that can be done on them is, I think, that of coming along now, why the world is kind of waking up to their research. So I don't know if I've mentioned this, but I've been writing this book and it shares three themes. One is to what extent do naturalist museums really represent nature, so the kind of the biases that they display in the natural world. If you're into insects or plants, hopefully you'll like that section of the book, which highlights how poorly they are represented. The second section looks at how they were really built, so who was really involved in making them, what were the kind of more troubling histories of how they came to be collections and why were collections built. And then finally, how can they help save the world? So I think there are ways the themes of the conference could talk to all of those. But what I'm going to do is just focus on this last one. And I'm sure some of these stories will be familiar to you, but what I'm going to do is just run through some of the examples that I came across for how naturalist museums can help save the world, that hopefully some will be interesting for you or that will be new for you. But it's kind of the aim is that people will have more tools to help advocate for our collections. And as I said, we have got this best record of life on Earth. So Hannah at an event the other day said that we're holding the receipts for the history of life on Earth, which I think is a really nice way of putting it. And obviously, since day one of naturalist museums, our collections have been kind of the repositories for the record of biodiversity, the type specimens. You all know this. But one of the interesting stories that I came across is, I don't know if you know about lag time in natural history museums, so the gap between a specimen being collected and it being described. The average is 21 years. But as you all know, often goes into the hundreds. This paper, sorry, it goes over 100 years. This paper is a particularly tragic story that I came across where a lizard was collected, a snake-eyed lizard was collected in Gujarat, Northwest India in 2000, and then was described as a new species in 2020, so far so normal. But in that gap, subsequent collections visits to that site in Northwest India couldn't find any more lizards, and it has been they collected one specimen in 2000, and it's since been considered extinct, largely as a result of traditional burning actually of the habitat to by kind of local people. And so in that time, we found out a species existed and now it no longer exists. And I think, we're kind of both poorer and richer for that knowledge because, of course, it's perfectly possible to imagine a circumstance in which that specimen wasn't collected and we would never have known that it was collected. And I think, I mean, obviously that provides obvious evidence for why it's important to resource museums and taxonomists in doing this. If we'd have been 20 years was the gap there, that is quicker than average, but still wasn't fast enough for anyone to do anything about protecting that habitat. So I won't labor the point on species descriptions because it's what we've been doing since the beginning. But as you all know, scientists are constantly adding new ways to use our collections, particularly when it comes to the notion of museums being nature's memory, which is obviously the book title. So shifting baseline syndrome, we've heard a bit about today. That's the idea that as generations pass, the concept of what is normal in the world shifts forward. So my concept of nature is as normal as in the 1980s and 90s, but my grandparents would be obviously generations before that. And if we're considering what is the baseline for conservation, many people would say before the Industrial Revolution. People can't remember that far back, but museums can. And so this is a collection that some of you might have heard about before. Leonard Jennings is it's not as famous as he should be in the history of science, but he is an interesting footnote in that he was the person that was first choice to be naturalist on the Beagle. And he said, no, thanks, why don't you ask Charles Darwin? And if he'd have said yes, would any of us be in a job? I don't know. Because Darwin wouldn't have gone. Anyway, he, instead of going on the Beagle, spent decades collecting in the 1820s to 1850s around Cambridgeshire, collected tens of thousands of beetles that we now have in Cambridge, insects that we now have in Cambridge, including these swallowtails, which now exist on only one site in Norfolk. These are from across East Anglia. We're now working with our local wildlife trusts using Jennings' specimen data and his notebooks to say this is what was in the fens before they were drained for agriculture. So the biggest habitat restoration projects in this country are happening in East Anglia, and we're working with the Wildlife Trust to inform them what species exactly were where and exactly what were the environmental conditions required for each of the species that Jennings recorded, so that they can manage the habitats for those specific species. So that's kind of I think for me, it's one of the best examples of obviously in the day-to-day conservation that natural history data is providing. Similarly, I've got a slide for this. Similarly, after the devastating bushfires in 2019, 2020 in Australia, southeast Australia, when 8 million hectares of habitat was lost, the bushfires just 5 years ago, 6 years ago. It is the herbarium data that are being used to record what was lost in that time as a use to guide restoration. That's that paper there. Incidentally, this has got a very human story as well, because this is a Cook specimen from Botany Bay, where they botanized for 2 weeks when the British first arrived in Australia in 1770, Eastern Australia, should I say. So these specimens, which are at the Natural History Museum, literally went to guide the invasion of Australia in 1788. But that's not the story here. And similarly, there's loads of stories like this. So the genetics of museum specimens of pine martens in Norwich Castle Museum are being used to find which population of pine martens was most closely related to the pine martens that were lost in East Anglia, so that if East Anglia was chosen for a site for reintroduction, they know which populations to source from. This is a really nice example from the mollusk world, where researchers were going through historic records of giant freshwater mussels in France and Spain, which they're critically endangered due to all the terrible things we've done to freshwater ecosystems. These are really big mussels, and they were looking for localities where they could reintroduce captive populations. And they actually found a record of a locality that they hadn't found in any other places. And they went and surveyed there to see if it was a suitable restoration site, and found an unknown population of living giant freshwater mussels. So that was a source of new like directing conservation rather than just informing it. So that's shifting baseline. There's the extended specimen concept, which I'm sure many of you are familiar with, but it's the most basic data that we can collect about a specimen is the what is it, where is it from, and when did it come from. That's kind of what those previous examples talk about. The extended specimen project as a concept is that they carry so much more beyond that. So we could take, we take the stomach contents of an extinct bilby, we could take the pollen off an insect specimen, we can take isotopes, we can to look at match their environmental conditions to exactly where they were, as we heard earlier with the kakapo. We can look at their hormone levels to look at stress. We can look at symmetry levels to look at stress and interactions. We can look at wounds. We can know everything and record everything about it on collections management systems. And it is astonishing to think to do this for over 1 billion specimens in the world, or even one museum with 2 million specimens. But it is happening bit by bit. And one of my favorite examples of this, you'll all know this specimen, Hope the blue whale, hanging in the Natural History Museum's entrance hall. In 2019, researchers at the NHM and elsewhere took one sheet of Hope's baleen. So the baleen is the sieve-like structures that grow in baleen whales' filter-feeding mouths, and it's made of keratin, like fingernails, which grows incrementally throughout an animal's life. So that sheet of baleen, which is consistently growing away from the gum, was a record of the last 6 years of her life. So they kind of took samples all the way down the sheet, and that proved that was evidence for different points in her life, and could basically track her movements by matching the sea chemistry to the chemistry in the baleen to see that, for example, she spent a year around Cape Verde, and then 3 years migrating between Cape Verde and the North Atlantic, then back to Cape Verde, where she became pregnant, gave birth, and then migrated north one more time, and then died at about age 15 in 1891 by stranding on the west coast of Ireland. Big whales, despite their size, are really hard to follow, to research. So these data are teaching us much about the movement patterns are really hard to study species. Similarly, there's elephants in Powell Cotton Museum that people have been tracking the migration patterns of the elephants by looking at isotopes from historic former ranges before habitat changes changed the migration routes. And this is a really famous example that many of you have seen, I'm sure. These are passenger pigeons. So again, plenty of human story here, but the pilot was in our museum, but then the biggest study was in the biggest museums in the US, where they took thousands of birds collected over 130 years or something like that, and ignored the fact that they were birds and just took the soot off of the feathers, which had been trapped on the feathers while the animals were alive. And over that time series, proved the best record in the world for environmental pollutants in the US. So how much coal was being burnt each year was tracked by the feathers pollutants, which I think is pretty cool. It was the best record for kind of for fossil fuel burning in the US over 130 years, which can then be matched to climate data to provide evidence for how those two things are interconnected. Smaller examples, people were looking at changes in isotopes in nightjar feathers and found that over time, the isotopes showed that nightjars have been feeding on smaller and smaller insects, so that the large insects have disappeared from their environments, because of the insect apocalypse. And that is, again, obviously not data that people who collected the nightjars would expect would ever be discovered, which is true for all of these stories. So yeah, obviously we are what we eat. And so these chemical isotopes are proving kind of absolutely transformative for how we can use our collections. Those are just a handful of examples from thousands of more, not all of which are in the book. And kind of over the centuries that modern museums have existed, the people, us, who dedicated our careers to caring for them have always known that we're important. But documenting the diversity of life has, as I said, has been core business for the museum since day one. But curators of centuries and even decades past have seen that as vital, but they couldn't have guessed just how urgent that work was. So they would not have imagined how the animals, plants, fungi, and data in our collections would be used, what questions they could answer, and the scale of the difference they're making in the fight against environmental breakdown. yeah, so the collections are vast, I guess, is the story, but the potential is even greater. I think I'm out of time, so I shall end there. Sorry? 8 seconds.
Does anybody have any questions? Oh, good.
Hi, Jack. Fascinating talk. I am wondering what you think of, I'm just thinking as I watch your talk about the gap in collecting, that natural history museums don't collect as much anymore, most of them, aside from some of the big heavy hitters. And we've much smaller collections from recent decades and century. And what are your thoughts on the risks associated with that in the light of what you're talking about?
Yeah, thank you. I think, yeah, it's a really, really important point. It's obvious that if we're using collections today that were collected 200 years ago or 100 years ago in ways that we couldn't possibly imagine how they're going to be used, then we need to continue these time series. You know, we've been collecting the same species in the same places, or different species in the same places, as it turns out, over the centuries. We do need to continue to do that. Obviously, we all know, well, the ethical and legal considerations that we have to take into account are really, really important. But that doesn't mean we should stop collecting. It might mean, and there's a statistic that, forget which country, I'm going to say Argentina. There are more Argentinian mammals in the Smithsonian than there are in Argentinian collections. And so if people are doing work on Argentinian mammals, it's obvious that they don't need to follow their compatriots to North America, but those collections need to be somewhere, so they should probably be in Argentinian museums. But I think, yeah, it's vital that collections continue to be made. Yeah, I think there's not a good reason to stop, that we can't replace this. And there's also not very, 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 very few examples of collecting have any impact on environmental conservation negatively.
Hello.
Jack, apart from publishing books with all these lovely stories, how do we get these messages across to the wider public
Well,
and awareness?
that's a great question, because I don't think that we in museums are particularly good at this. I think that particularly research intensive organizations, and I include mine in this, that our gallery, you know, one of the points of the first section of the book is that all of our natural history museums are basically the same. We all say the same things about the same animals and plants, in my case, just animals. But we don't say this is what's going on behind the scenes in this museum particularly well. And I think we should be doing a better job at that. I think people aren't so aware that there's hundreds of researchers behind the scenes doing this stuff. And I think that is where we can tell unique stories that make the galleries different from each other. So I think museums have a big role in that. Absolutely. Well, she's walking over. I have got a few copies of this book left if you want to see me after.
I wanted to share a thought about this extended specimen. One of my favorite works is how one study went for the bird nests and found out what plants are in and what protists are in there. So it was like very obscure herbarium and collection of like one-celled organisms. So yeah, that's really one thing we should think about, how different collections, disciplines are working together, like how herbarium people are working with, for example, bird collectors. So yeah.
That's really cool. Yeah, I didn't know that one. Thank you. All right. Thanks.
Is it brief? Does Jack or anyone in the room have good examples from the marine sphere?
Okay, no, that's not a brief question.
Yes, in the book.
Apologies, there's not enough time to discuss such a lengthy question. You could discuss it online and message Jack if you want more information about it and etc. Apologies online for that one.